Creating families for Revit MVP is very difficult and time-consuming, especially for the first-time user. To make it easier on your other team members, it might help to create family templates of your own that have already been set up to a point where they can begin to fashion their own families. In this case, we're going to look at several techniques which will make this process available. Under Families here, I'm going to select New. You'll notice that there are several templates provided by the out-of-the-box content. And in this case, I'm looking for one to create mechanical equipment from, but you'll notice that there is not a mechanical equipment template. However, I do come across several generic model templates. Most of the templates provided here are set up to a pre-designed category assignment. Categories actually control the visibility and the graphics of the family, also how they schedule. In this case, generic model seems to be the best option since I do not have a mechanical equipment template. But then I got to ask myself, is it going to be hosted? You'll notice that above just the base generic model template here, I have several hosted families. I can use a face-based family, which means any surface of any object in my model can become a potential host. I got a floor-based one, which allows me to anchor to floor elements. I got one that is roof-based, which allows me to anchor to roofs, and so on. In this case, my equipment's going to be level hosted or just standalone, as we call it. So I'm going to select a generic model template. You'll notice that the family launches in the family editor. It is called Family 1 in this case. And the reference level plan view is currently active. But if I type in WT, you'll notice that several views open with this template. I'm going to type in ZA now to zoom all the views to fit. And I can see that I got a reference level plan view in the upper left. I got a 3D view, view 1 in the upper right. I got an elevation view left on the lower right, and an elevation view front on the lower left. Now before I go any further, what I have to do is decide what category of elements am I trying to create here. And before I go and create anything, I'm going to come up here to the Properties panel of the Home tab and select the Family Category and Parameters button. What this allows me to do is select a category assignment for my family. Because I chose generic models as my template, generic models is currently selected in the family category list. But that's not what I'm trying to create for my template. I'm trying to create mechanical equipment. So I'll come down the list here to mechanical equipment and choose that as my option. I'll select OK. Now that that's been taken care of, I can begin to create the skeleton work of my family, or the context of where the model geometry will live. You'll notice that when I look in my plan view here, I got two reference planes. And when I select both reference planes, the little pin icons will show up. This means that they're fixed in space and cannot move. Another feature about these two reference planes that currently exist in my template are that they're named. If I select the vertical one, I'll look over on the properties here and notice that the name of the reference plane is called center, left, right. That means that this is the left side of my family and this is the right. The left side in this case coincides with the left view over here. If I pick the horizontal plane, I'll notice that this is called center, front to back. So in this case, if I'm looking at plan, I can see that the front side would be down here on the lower edge of the view, which coincides with the elevation view front here. Another interesting factoid about these two reference planes is that they both define the origin of my family, as indicated by the defines origin parameter here. So where they intersect each other is where the insertion point of my family exists. And again, you can choose to relocate this when you make your own family. Now almost all families, or 3D families for that matter, exist because of three vectors, X, Y, and Z. And what we'll do is use reference planes to define these three vectors, using our multitude of views here. I'll start off in the plan view. On the Home tab here, I'll come down to the panel that says Datum on it. And you'll notice that there are two tools here, reference lines and reference planes. If you're going to use angular relationships in your family, you want to leverage the reference line tool. If you're going to use simple surfaces or work planes to control the context of your family, what you want to use is reference planes. And that's what we're going to use. So I'll select the reference plane tool. And my ribbon will immediately adapt to contextual tools for me to draw my reference plane. I can actually draw it myself by picking a straight line or drawing a straight line. I'm going to draw a straight line in this case in my plan view. So I'm going to define the back surface of my mechanical equipment in this case. Then I can create the side surface of my family, which I'm making a template for. And then I can create the front surface and then the left surface. Now since I'm in the command, I can click on down here in the front view and draw the top surface of my element that I'm trying to create here. So as you can see, this creates the context of where my model will exist in 3D space relative to the insertion point. Now, one of the other key features about reference planes is their ability to be used as work surfaces to model on. If I wish to do this, it would help if I would name these. It also helps to orient the user to which direction is what when they're looking at the view. So in this case, I'm going to pick the back reference plane that I drew here and just simply name it back. Once I hover back over into the view, you'll notice that the word back appears by the reference plane. If I repeat the process for each of the reference planes I created, you'll see the same results. So as I move from view to view, I can get an idea of what I'm looking at when I select these reference planes. And this helps tremendously when you're developing your family. The other benefit is if I wish to switch the work plane in which I wish to work on. So if I use the Home tab here and come down to the Work Plane panel and select Set here, you'll notice that it brings up the Work Plane dialog. And because I named all those references, I can choose them as objects to work on. This could be hugely beneficial in the future. Now I have to create some relationships or parametric relationships. Before I can do that, I need to create some basic constraints. So I'll select the Annotate tab and utilize dimensions to do some basic constraints, such as making the surfaces equidistant from the center. This is simple to do by selecting the Align dimension and picking all three vertical references that I've created. Once I've placed my dimension, you'll notice that an equality constraint symbol shows up, and I can toggle it on by selecting it. What this allows the model to do is if I pick this surface, in this case the right reference plane, and drag it to the right, you'll notice that the left plane moves equidistant from the center the distance I pull the right reference plane. This is a behavior that I want to exhibit in my family as it grows and shrinks to the different sizes I wish to create. I'll repeat the process on the right side. So you notice now the front and the back will equidistantly grow as I pull and push the reference planes apart from one another. Now that I have that relationship in place, I need to create some just basic overall dimensions, X, Y, and Z. So I'll go back to the Annotate tab and select the same dimension tool, or right-click and repeat the process. I'll simply pick on the left and the right reference planes that I've generated and place a dimension, and then the front and the back, and then back down here in the front view, the level that's currently in there, and the top reference plane. Now with that all in place, I can go again and add labels to these dimensions. Labels are parameters that are added to the dimensions to flex them. So if I pick this reference dimension in here in the plan view, you'll notice that up on the options bar here, I get a label pull down. I can also right-click and pick label from the menu. So either way you do it, you're still going to add a parameter. Now this is where the fun begins. Whenever you're building families, you'll find yourself constantly creating parameters, and if you feel like you're doing the same parameter over and over again, you probably are. A way to minimize this effect is to use shared parameters. Shared parameters offer a level of consistency and expected results. So by clicking Share Parameter here, I can go and select from a text file that lives outside of Revit a list of shared parameters. So I'm going to hit Select here, and this will take me to my shared parameter file that I've already created for this exercise. Now if you had to create your own shared parameter file, it's quite simple. You would get a series of dialogues which would ask you to create one because one does not exist. In this case, because I already created it, I'm getting a series of different dialogues that you'll probably see if you don't. Once you get to this location, though, you can create one, and it's simple as hitting create, and then giving your shared file a name, and you'll see it gives it a txt extension. After you save that to a centralized location on your network for others to access, you can begin building your share parameters. The first thing you have to do is build a group. You'll notice in my share parameter file I have several groups already established. This helps to further organize your parameters based on task or need. To create a group, I simply click on New here under Groups, and then I enter a name and hit OK. If I wish to rename the group, I can click Rename. If I wish to delete the group, I can delete it. Once I've established the group, I can begin to build my parameters. So you'll notice that I have a simple dimensions group. I've already created some dimensional parameters in here. But in this case, I do not have length, width, and height. So I'm simply going to come over here and pick New under Parameters to build them. Now I'm in the Parameter Properties dialog. And this is a lot smaller than the Parameter Properties dialog I got back here when I initially started the process. Because all I really care about in the shared parameter file is the name of the parameter, the discipline it supports, and its units, in this case length. So I'm going to type in the word width. And then I'm going to hit OK. And you'll notice that my parameter pops in there. Now I need to create one for length. So I'll select New again, type in the word length, and hit OK. I'm leaving these as common discipline parameters set to length for the type of parameter because that's basically what they are. Last but not least, height. Now in future families I can reuse these parameters, and then when I go to my schedules I always get a consistent value for width, length, and height, no matter what family it may be. And this is where I start to build in the standard. So as you can see, share parameters go a long way in that kind of sense to give you that expected result. So once I'm done editing my share parameter file, it takes me back to allow me to choose which parameters I want to specify for my label. So I'm going to select width here and hit OK. Now what I have to choose is where to group the parameter under. And we'll see where that goes in a minute. In this case, just rely on dimensions because it is a dimensional property. And last but not least, whether it's type or instance. So in my family, is this parameter going to drive types in the family, which are various sizes, let's say, or various configurations, or is it going to be a parameter that drives an instance in my model, you know, like AHU1 or AHU2 and so on and so forth. Even though they might be the same exact unit, they might have different values associated to them. So in this case, it's going to be type because I'm going to have different sizes of mechanical equipment, obviously. And I'm going to hit OK. Now I want to choose this left overall dimension and repeat the process by adding length to that as a label. So I'll use my share parameter file, use the select command, go to my dimensions group, and select length, and hit OK. Check the group it's under, check whether it's type or instance, and then select OK again, and my label is added. Now last but not least, my height. I'll come down here and select a dimension, pick my pull down, add my parameter, select the shared parameter file, and go in and select height. Now obviously when you do these kinds of things like adding labels to dimensions, you want to flex your model. So to do that, we can do it one of two ways. We can pick the dimension in the view and change the value. And if the value moves, we know that it's working. Another way we used to do it in the past releases before we were able to do in-place editing like that is through the Family Types dialog on the Properties panel here. When I click on this, it gives me a list of my parameters currently in the project. And you notice that the three parameters that I've labeled on dimensions here are occurring under the dimensions group like we specified. So here again I can flex the model. So let's change the length and the height this time and hit apply. And we'll notice that in both the front view and the plan views here, things have changed. It's working perfectly. Okay, now that I've specified some basic vector information, I can begin to model the forms. And again, most families can be represented in the MEP model with just cylinders and boxes. You don't have to get really intricate because really the information on the model objects is what's really important. We can rely on symbolism to emulate the plan set representation or the elevation set representation for highly detailed information on the model, but for now we're just going to use simple boxes and cylinders. To do that, I'm going to resort to the Home tab to select the Forms tools. I'm going to select the Extrusion tool because it's the basic tool to create a shape and extrude it to a height, which is what we have here. So I'll select Extrusion, and it puts me into sketch mode in the view I'm in, reference Plan 1. And you'll notice that the ribbon has changed to give me the drawing tools that I need, and I'm going to select Rectangle. I can check my work plane over here on my properties to see if I'm currently drawing on the reference level, which is indicated here in my views on the left and the front. If I had to change it, I can come up here and hit Set. So keep that in mind when you start to model. Now I just need to snap to the intersection of my reference planes, my contextual elements. Remember, that's why we created them. So I'll select the corners, and then I get these padlocks. This allows me to constrain the sketch of my box here to the reference planes, which are being flexed by my label dimensions. So if I lock those up, my sketch of my form here should stretch with my reference dimensions that are labeled with parameters. Now I can hit the Finish check mark up here to finish my mode. This takes me back out into the primary model. Now you notice in 3D here that it looks like a 3D shape, but in my front and left views it's just a little short of the mark. So to make it as high as my top reference plane here, I can drag the shape handles here up to the reference plane, and then it will give me a padlock to constrain it. So if I simply click the lock here, I can now change my elevation of my object, and you'll notice that it flexes the cube. Now the next biggest component of your Revit MEP families are connectors. Connectors allow the device or equipment to connect to one another so that it can communicate flow information or pressure drop information or any kind of circuitry information. So to do that, we resort to the connector tools. So if I select the Home tab here and come down to my connectors panel, I got a series of connectors to choose from. Let's just use the duct connector as a guinea pig for this example. When I pick the duct connector, I get two placement options: face or work plane. Well, I'm going to use my 3D view to illustrate this, so I'm just going to maximize it for the time being. And if I select face here, you'll notice that it lets me highlight any face of my 3D object. Now, the downside to using the face option is that it centers the connector exactly in the center of the surface. The problem with this is it's fixed to that center of that surface, and I cannot move it left, right, up, or down in any kind of direction. However, if I use the work plane option, remember we created references in our model that are named, I can pick any reference that I wish. So in this case, let's say top. And you'll notice that it picks the top reference plane. And when I hit OK, the connector hops in there. But the beauty of this is, once I go back to my multiple views here and click inside my plan view, you can select the connector and you can use dimensions to drive its ultimate location here. I can actually make these permanent dimensions and label them with parameters to make it movable. But again, it's still stuck to that one surface. What if your device has the connector on the right side, or maybe in another instance it's in the front? This can become rather difficult using this type of technique. So rather than use that technique, let's undo a couple steps and look at another method. Families can be hosted to other families, or nested as we call them. It's as simple as loading a family into a project, but in this case you're loading a family within a family. But first we have to build that family that we would load into this family. Let's explore the technique. I'm going to come up here to the Revit application menu and hover over New and select Family. And this is where those generic model hosted families come into play. We have one called Face-Based. And the beauty of Face-Based is it doesn't care which surface it hosts to as long as it's a surface. So I'm going to use that as my tool of choice for creating my necks of my connectors, let's say. When I select Open, it's going to give me a generic mass in here for which to represent the surface of the host. Now all I got to do is repeat the process of creating my context. So in here, in this model family, I'm going to create reference planes. And notice that I'm creating the references about the insertion point, much like I did with my host family of the cube for my mechanical equipment. Again, I'll use dimensions to create relationships equidistant from the center. Then I'll create overalls. Now that that's complete, I can add labels to these two dimensions for the overall size. In this case, I'm not going to use share parameters. I'm just going to use something simple like a family parameter because I don't need to report this information in this family. So I'm just going to call this width. This will be the width of my connector. And I'm going to make it instance-based because each instance that I place in the model can have different sizes. So I'll select OK. The next thing I'm going to do is the width, or excuse me, the height. So I'm going to change this one to the height. And again, make it instance-based. Okay, now that I got that set, I'm going to just give it some generic sizes here. Let's say like 2. Make sure it flexes by 1. And as you can see, it's flexing perfectly. Now again, I'm going to resort to creating my geometry. I'll go to the Home tab and select my extrusion tool. Use my rectangular option because I'm making a rectangular neck in this case for duct connections. And I'm going to give it a default height of 1 inch. Just enough to give it a neck. So now I'm going to go in and snap to the corners again of my references and lock them in place. And when I finish, if I look at the 3D view of this family, you'll see that it's just 1 inch high off the posted surface. That's my extrusion in this family template. Alright, now that I'm done that, I'm going to go load it into my host family, which is my mechanical equipment family template. I'm going to select load into project from the ribbon here. And if I click inside my 3D view, notice that this face-based family allows me to place this neck on any face. Kind of like what the connector was doing, but with more power. And you'll see this in a minute once we complete the process. But I'm going to hit modify because I'm not going to place my connector just yet. And also I'm going to tuck this family template that I used to make the neck off to the side for the time being. In my project browser down here under families, I'm going to go look at the generic model family that I just nested in here. It's called Family 2. And I'm going to right click and rename it. I'm going to call it Rectangular Neck. Underneath the family, I'll see the initial type, Family 2 as well. And I'll rename that as 1 inch. Okay? Very simple to do. Now what happens if you have pipe connectors? Pipe connectors are round. So we'll probably need a cylindrical neck. So I'll resort back to that family I just created for my rectangular neck. And just undo a couple steps. So I'll just go back a couple steps here to the initial template that I started with. And I don't need a lot of reference planes with a circular neck or a cylindrical neck. I'll just have to create a cylindrical sketch for my form. So again, I'll go to the extrusion tool and I'll create a circular shape for my sketch. I'll snap to the center insertion point of the family and pull out a circle. And what will be left behind is a temporary dimension of the radius. Round duct and conduit and pipe are all measured by radius, but we input the diameter value. So initially underneath the hood of Revit, everything's based off a radius, as you can see here, indicated by the 7 inches of this circular shape. I'm going to convert this temporary dimension to a permanent dimension, and then I'm going to label it as its radius. So simply click on modify here. I'm going to pick the dimension and then add a parameter label. I'm going to call it radius. Again, under dimensions, instance based, just like I did for the rectangular neck, and hit OK. Again, I'm going to go and resort to my tab up here, modify, create extrusion, and I want to give it a base height of 1 inch. So let me get out of that selection mode there so I can change the extrusion height. And I'm going to change it over here in the properties to 1 inch, and then I'm going to hit finish. And again, if I go to the 3D view 1, you can see I have a cylindrical neck 1 inch high. Now, if I click on that, I can go in and change its properties, but I can't do it much like I did the neck here for the rectangular shape. I have to do it from the family types. And there you can see my radius parameters. So if I change it to 1 inch here, and then I pull this off to the side and hit apply, you'll see that it changes the shape. Now how do we get diameter? Well, it's quite simple. We just add a parameter called diameter. So I'm going to call one diameter in here, make it instance space, length, and under the common discipline, and hit OK. And I'm going to type in, let's say, 2 inches for the diameter. And we all know that radius is 2 times, doubled to create the diameter. So in the formula for radius here, I'm going to take diameter and divide it by 2. And if I hit apply, I can go change the diameter to 3 inches, and you notice that Revit does the math. And it's also changing the format here. Very easy to do. Now I can go nest this family into my mechanical equipment template, so I'll hit load into project. And in this case, I can get rid of it. I'm pretty much done with that now. And if I look under my families, I got a new one in there called Family 2 again. And this is my round neck, so I'll just right click and rename it round neck. And if I expand it, I'll call this one 1 inch as well. So now that we got our necks created, we can go and add them at will. So if I go and want to create a duct connector, I'll just pick my 1 inch neck here, and I can drag it out into the interface. Or I can click in the view and go to my Home tab and select the component tool, and then use the type selector on the properties to pick which type of neck I want to drop in there. So I'll choose rectangular neck, I'll pick place on face, and then let's just say that the connector for the supply side will be on this side right here. And if I spin the model around, the return will be down here on the back side. Okay, so you can see that it's real easy to place these. I'll just switch to wireframe so we can see through the model at the necks that we placed. Now while I'm in the command, let's say we need some pipe connectors for the coil if this was going to be an air handling unit. Or maybe I need a condensate connector. So I can just pick my round neck here and just drop it on any surface. So let's say that they're going to be on this side here. And there's going to be one right there. And I can hit modify. Again, I can use dimensions to locate these. So if I go to the front view and I use my dimension tool, inside those families that we created and nested in here are references. There's the center reference of that family this way and the one this way. So if I wanted to, I can create a dimension from here to here and add a label so that I can move it up and down on that surface. Or from the center to the center and move it left or right. Or maybe to keep it centered, I can constrain the center of this to the center of the host. So there's a lot of opportunity here for flexing and making this configurable. But as you can see, I got my necks in place now for, let's say, pipe and duct connectors. And I can make another bump out, let's say, for an electrical box or just a disconnect switch or something like that. But we'll just utilize that. Let's say we do that right now. We'll just drag that out. And maybe the disconnect's going to be here. And let's say the size initially is going to be 8 inches by 6 inches. And we'll just put it up here in that corner. Okay? Very simple to do. Not much to do with it. I can move that anywhere. Okay? So now we got that placed up, we can go put our connectors on. And I'm going to go to the Home tab and go to my connector tools. So I'm going to select my duct connector. Let's work with them first. So on my duct connector tools, I'm going to pick the system classification on the options bar, supply air. So supply air is coming out this side. You'll notice that when I hover over the face surface of this neck that I placed, I can click on it. And I get the width and the height parameters of the connector. Now you want to be very sure that when you place the connector, this little green arrow is pointing away from your device because that's the side that the duct's going to connect on. If it's pointing inward, the duct's going to try and go around and into the mechanical device and then connect that way, and that's improper. So make sure that that arrow is pointing out. And one other thing to note about it, it does not designate flow. The X on this connector indicates that it's the primary connector too. This is the connector that will most likely be used by schedules to pull data from. Now, if I hit modify here, you'll notice that when I move the neck around, that the connector goes with it. Okay, so here's what I'm talking about making it configurable. So if I pick this neck that this connector's on, and I use the pick new host option if I want to configure it to be on the top, look at how easy that is. I couldn't do that by just putting the connector right on the object. So by creating a face-based family and nesting it in here, I get the best of all these worlds. So I'm going to pick the new host and put it back on the front like I had before. And I'm ready to configure the connector. So the first thing is the size. I want the size of the connector to match the size of the neck. But we haven't done a lot to automate this process. So the first thing I want to deal with is the neck. So I'll pick the neck, and you'll notice that there's those width and height parameters we created. So I'm going to select the Associate button next to the width parameter. And what I can do here is map it to a parameter in the host family so that the host can flex it. But I don't have one. So again, this is where share parameters come into the aid. So I'll pick my add parameter button there on the associate family parameter dialog, select shared, and then hit select. And I've already pre-created some additional parameters to do just this process. So I'll select supply width, hit OK. I'm going to make it a type parameter because each type can have different size connectors. And I'll hit OK. And it pops right in there. Now I'll do the next one, height. And then I'll map it to the share parameter from my share parameter file. Supply height, hit OK. Make it type base, OK and OK. Now you'll notice in the family types dialog, I have share parameters to control the neck size, width, and height. But it's not controlling the connector yet. But now that I have the parameters shared to the family, I can go pick the connector, and the connector has the same two parameters that my neck has, width and height. So I'm going to select width first and map it to supply width, hit OK, and you'll notice that it stretches to 2 feet. If I do the same thing for height, map it to supply height, it stretches out like so. I'll just repeat the process on the return side. So I just need a connector. So I'll pick my duct connector, change my system classification to return air, and pick that surface. Now I just need to map the parameters of the neck. So I'll go and pick width again. And again, I'll add a share parameter, which I've already pre-created, return width. And then I'll do height. So I'll pick the height associate button, add a parameter, shared, select, return height. Now I can just associate the connector's parameters to the same share parameters in the host family. And another thing you should note about the connector here is if I pick it, I can actually associate the height and width right on the connector in the place of the view. So if I pick the plus symbol next to width, I can pick return width right away instead of finding it in the properties over here. So you choose the way you want to do it. I can do the same thing for height. So again, like anything, I want to make sure that this flexes properly. So I'll just get to a view angle here that I can see this. Open up my family types dialog, and let's make some changes here. Let's say that this is going to be 1'6" by 8, and the return is going to be 1 foot by 6 inches. And if I make sure height is 8 inches up here, and if I hit apply, notice that the necks and the connectors flex. And like I said, you get the best of all the worlds of removing them and putting them into a new location. So if I pick the connector neck, I can pick a new host and put it up there. All right. Now those darn pipe connectors. Again, I'll maximize the view. So here, let's say I have a coil that I want to simulate inside this family template. So I'll go back to my connectors on my home tab and pick pipe connector. And then I got to pick the system classification. So in this case, I'll pick, let's say, hydronic supply. So I'll supply low here, let's say. And you see it puts the connector right on the surface of that nested family of that round neck. And again, I'm going to have to do the same process that I did with the duct connectors. So I'll start off by picking the neck. And you'll notice I have a diameter parameter, which I've created in that family. And I'm going to associate it. Now, I don't have a parameter inside my family, my host family that is, to control it. So I'll add it. And again, the share parameter will come to my aid. So I have one in here called chilled water diameter, and I'll hit OK, and then OK to add it to my host family, and then OK to associate it. I'll resort to the same technique, but you'll notice that the connector uses radius. So the unfortunate thing here is when I pick my connector, I have to go map it to a parameter. So again, I'll have to add a parameter to my family, that host family that is, which will be shared, and I got my chilled water radius connector parameter. So I'll hit OK, it'll be type base, and OK. And I'll hit OK, and you'll see that it's mapped to that. But if I go to the family types dialog, what I have to do is kind of the same thing I did in the neck family. I have to create a formula. So I'm going to select inside the formula for chilled water radius, and I'm going to type in chilled water diameter divided by 2. Okay, and if I hit apply, you'll notice it stretches down to 1.5 inches, as expected. Now I can go put my hydronic return connector on. So again, repeating the process, pipe connector, hydronic return this time, put it on the face of this neck. I'll go pick the neck now, and I'll associate its diameter parameter to chilled water diameter I'll pick the radius connector parameter here and associate it to the chill water radius, and boom, we're in business. Now, when it comes to electrical connectors, it's just more or less logical. There's no physical point in putting it on any surface because as long as it has a connection, the electrical engineer can connect to it. Now I'm just simulating it by putting it on this box so I can move the box to any side of the object I wish to when I make my family. So I'm going to go back to the Home tab and select the electrical connector. And what I'm going to do is make sure that I pick the power balanced system classification. What this means is that if I have a multi-pole circuit, it will be balanced across all the phases of that circuit. So I'm just going to pick the front face of this box, which will emulate my power connection point. And it puts my power connector right on there. And that's really all I got to do. And as you can see, if I want to pick a new surface for that power connector point, I can move it anywhere I wish. It's a very, very powerful feature, that face-based family nested into this host family. Alright, now that I have all that set up, I have to set up the connectors for their system's information. Let's start with supply. So the first thing I got to realize is that this is the source of air for the supply air system. If I'm making a template for my air handling units. So I want to make sure that this connector is calculating the total demand downstream. The air coming from the unit is going to be flowing out of the connector to supply my terminals and VAVs and whatever is downstream from it. There's the system classification, so if I missed it when I inserted the connector, I can choose it right here. And then I got the loss method. So if there's going to be some pressure loss at this connector, I can define it here. In this case, it's going to be coming out full force, so there's probably not much of a pressure drop. But that darn flow connector parameter is going to be very important. So again, I'm going to associate it to a parameter in my family. And I'm going to use shared for this case. Now this time I'm going to change over to my group mechanical air, and you'll see that I have a supply airflow parameter already created. If you take a deeper look at this, it's a little bit different than the dimensional parameters we've been creating. So I'll just edit my shared parameter file to show you what I mean. I'll go to my mechanical air group here and select supply airflow and look at its properties. I placed it under the discipline HVAC using the unit's airflow, or CFM in this case. Very, very important. So make sure that you map the parameter types correctly if you're going to make shared parameters for them. Okay, so I'm just going to cancel my way back, hit OK. And what I want to do is make sure it's an instance parameter, because each air handling unit can handle various flows, let's say, even though they're the same type. So I'll hit OK, I'll hit OK, and you'll notice that now it grays out. Now I'll do the same thing for my return. So I'll pick my return connector. It's going to be calculating the return air coming back to the unit as well. Air is going to be flowing into the unit in this case. And I might have a little bit of a pressure drop at this case, so I might use specific loss. Now I don't have a pressure drop parameter in here per se, but I could build one, and if it's really important to schedule and reutilize over and over again on multiple families, I'll make a shared parameter. So as you can see, it's going to be a type pressure. I'll just pull this over to the side so we can verify that as we make the parameter in our shared parameter file. I'm going to go to the shared parameter file itself, and I'm going to go and edit it. And again, this is going to fall probably under the realm of mechanical air. So I'm going to make a new parameter. And here's where that first dialog can help us out. You see the word pressure here? That's going to be really key. So I'm going to call it pressure drop. I'm going to put it under HVAC. And if we look under the type of parameters here, we'll find the word pressure. So we'll know that this parameter will work well with this parameter. So I'll hit OK. I'll hit OK to exit editing my shared parameter file, and then I'll choose it. And again, this will probably be type-based because each unit probably has a defined pressure drop from the manufacturer. So again, I'll hit OK and OK, and now it grays out. Now we'll do the same thing for flow. So we'll have a dedicated return airflow parameter, which was made in the shared parameter file already for us. So I'll just go pick it. And again, make it instance-based and hit OK and OK. Now for the water connection points, I'm going to pick my supply connector down here. And I get to the flow configuration. Now in this case, the air handling unit is going to be receiving water, so it's putting the demand into the system. So it's the downstream device. So I want to make sure that my users can preset that value. Where's the water going? It's flowing into the connector, so I'll make sure it's in. Is there a loss method? Absolutely, so I can probably pick specific loss. And then if I look up a bit, there's a parameter here called pressure drop. So if I click on that, I can go add a parameter. In this case, I'm going to designate it differently than their average air parameter, pressure drop. So I'll make a new parameter in my shared parameter file under pipe. I'll create a new parameter again, and I'll call it chilled water pressure drop. Put it under pipe this time, and again, I'll put it under pressure. So I'll hit OK because it's a piping connection. I'll hit OK to stop editing my file, and then change my group up here to pick my new parameter, chilled water pressure drop. And again, I'll make it type-based because, again, the manufacturer will probably specify this. I'll select OK and hit OK. Now the other thing I got to combat here is flow again. So I'll hit flow, and I don't want to select the airflow options. I'm going to go add a parameter for them. So again, my share parameter file again will come and help us out here. I'll go to my mechanical pipe group and pick my chilled water flow. And again, this could be instance-based, or it could be type-based. Probably type-based because the manufacturer probably specify what the coil demands are. So I'll hit OK, and I'll hit OK again. Now down here I can add a description, especially pipe connectors, to really help your family that has multiple connectors out. It's good to give a description, so I might put in there CHWS inlet. Now I can work on the return outlet, so again, I'll come up here and make sure that it's preset. I'm going to say it's flowing out. And the loss method here is going to be the same. So I'll do specific loss, configure to the same parameter, so I'll associate pressure drop to the chilled water pressure drop, and then I'll associate flow to the chilled water flow. Last but not least, I'll come down and give it a description, chilled water return, outlet, hit apply. Now I'll just spin around to my electrical connector, which is the last guy here, the last guinea pig in the series of connectors here, and I'll pick him. And what I want to do is be able to manage the voltage and things like the load classification so that the electrical engineer has full control over that. So I'll map those parameters. But before I go any further, I'm going to make sure that the number of poles is set to 3 because this could be very key. So I'm not going to associate that. I'm just going to bump it up to 3 right away. And again, if it varies on your family, you can make a shared parameter for that and associate it. The load classification, though, I want to make sure that they can manage that from the project, so I'm going to associate that. And again, I'll add a parameter, and I've already created it in our shared parameter file. So I'll go to my electrical power group. I'll pick my load classification parameter, and just for giggles, we'll take a look at how that's made. So I'll go into the edit the shared parameter file, go to electrical power, pick load classification, and if I look at the properties of it, you'll notice that it's under the electrical discipline, set to the type of parameter load classification, just as indicated back here when I go to associate it. So if I cancel back and pick that parameter, again, I'll leave it type-based or instance-based. It doesn't really matter. It just depends on the situation. Hit OK, and hit OK, and it's grayed out. Now the family controls it. Last but not least, my voltage. So I'll pick my voltage parameter, and I'll add a parameter in here, shared. And again, this could be shared or not. So I'll go to electrical power, pick my voltage, hit OK, pick type, and so on. Because I might want to schedule that information. If I want to do that for a parent load, again, I can map that as well. And you'll notice that I don't have one under there, so I just need to edit my share parameter file. I'll go to my group, electrical power, and add a new parameter. I'll call it parent power. Put it under electrical. And under the type of parameter, apparent power, because that's what's indicated here. I'll go and pick it now that I've made it. I'll make it type-based and OK, and OK. So now if I go back to my family types here, you'll notice I have made all these parameters in here. So I can say it's like 1500 volt amps. Voltage is 480. And then I can pick a load classification from the family here or once it's placed in the project. Very, very powerful. Okay, so now that my template's been made, I'm just going to go and close all the other views of my family. So I use the close hidden window here, and then I'll save the family to my location where I'm creating my templates. So I'll say save as family, and I'll put it in here as mechanical equipment. Hit save. And now I can close the family. Now if I go to open the family, I'll go to that folder, and you'll see it says RFA on the extension. But that's not how we make templates. There's no save as RFT in this case, so I need to use a little rename option in Windows. By right-clicking on the file, I can change the extension by renaming it to RFT. Once I do that, it'll disappear from the screen because it's no longer an RFA file or ADSK file. So if I hit cancel here now and select new and go to the location where my template is stored, there I can use my new template that I've created to build a new family. Once created, I can go build types within there by selecting new, giving it a name, and changing any of the values that you see here. So very simply put, putting a little effort in the front end of creating your template can go a long way to creating future families for your company.